There are two things that we want to do in this video. One is to show you the shapes of a couple of conic sections, ellipses and hyperbolas that you may or may not have seen before. And the other is to make sure that from any given equation, if it's an equation of a conic section, that you can recognize which conic section it would be. We're not actually going to graph these. If you're going into pre-calc next year, you'll spend plenty of time with these shapes and graphing them and finding other things out about them. But for now, we just want to be able to recognize what shape comes from what kind of equation. So this neat, I don't know, maybe it's neat, image is just a bunch of overlapping conic sections that you can see here on the left. And we can take some of these away just to look at the shapes one by one. We've spent plenty of time with hyperbolas, so we know what their general equations look like. They're either y equals x squared or x equals y squared, but there's a couple of parabolas. And of course, we know what circles look like, and we've done some work with them as well. Here is a hyperbola, and I'll put in a second one as well. And you might start to notice the differences in the equations that produce circles versus hyperbolas versus parabolas, but we'll cover those rules in a minute. So the one in purple, we would call a horizontal hyperbola because it has two sides, left and right. And just to show you, if we extend out, it keeps going infinitely in those directions. Whereas a vertical hyperbola has top and bottom portions, and again, extends out infinitely in either direction. And then finally, we will put up a couple of ellipses. So an ellipse is a lopsided circle, essentially. And similarly to hyperbolas, there's vertical ones and horizontal ones. So those are the four shapes. Let's look at some equations and the rules for how we would determine which shapes each equation produces. So let me go back to the whiteboard here. Okay, and these are the rules. So if you're taking notes on how to recognize conic sections from an equation, these are the notes that you would want to have. And so you may want to just pause the video, write these down, and then come back. Okay, a parabola, we've seen plenty of these before. If we have y equals x squared or x equals y squared, and of course, we can put any transformations in that we want. We're just talking about parent functions here. So if we have like 3x plus 2 equals 4y minus 7 squared plus 8, that's still, the x is not squared, the y is. It's still just a version of that. And so the rule that we would say for parabolas is that if one of the variables is squared and the other one's not, that's going to be a parabola. Okay, circles. If they're both squared and they have the same coefficient, circles are, of course, symmetrical in all directions. They're just as tall as they are wide. So it makes sense that like the x numbers and the y numbers would be the same. And it also might make sense that since an ellipse is a lopsided circle, that it should be kind of like a circle equation, but with something making it lopsided. And what makes an ellipse lopsided or oblong or whatever we want to call it is that these coefficients are different. Again, we can have the same transformations as we do for other things. So we might have like 4x minus 5 squared plus 2y minus 1 squared equals whatever. And so you might guess that this would be centered at x equals 5, y equals 1, and that's exactly right. And again, beyond that, we don't need to know exactly how to graph these right now. Finally, hyperbolas, they're kind of their own thing, but we've seen some squared and added together formats. Hyperbolas are squared and subtracted, either x squared minus y squared or y squared minus x squared. This would produce a horizontal hyperbola like that. This would produce a vertical hyperbola like that. Let's look at four equations and see if we can use these rules to figure out what kind of conic section we're looking at. So here's the first one. Again, if you want to pause and take a moment to check it out, you can. So we would look at this first one and say one of the variables is squared, one of the variables is not. Now, yes, there's also this, but is x squared? Yes, it is. Is y ever squared? No, it's not. When one's squared and the other's not, that is a parabola. We'd want a little bit more information about this though. So let's put it in our usual format, would be, in this case, y equals, we would say, there we go. We would say, since it's y equals x squared, it's vertical. And since it's y equals negative x squared, specifically, it opens down. So that would be our basic information about this shape. It's a vertical parabola, it opens down. The second one, we would say the x is squared, the y is squared. Again, there's these other terms, yes, but is the x squared? Yeah, it is squared at some point. The y is squared at some point. So both squared, same coefficient, both 1, and added together, that means it's a circle. And we have other things that we can do with circles, but for now, we'll leave it at that since we've covered those other things. Third one, we have, again, squared added together, but this time different coefficients. So it's like a circle, but lopsided. That's going to be an ellipse. And then for this last one, I've put the same thing in two different formats. You'll notice, for example, I'd have minus 2y there, pardon me, minus 2y squared there, and added it to the right side over here. So these two equations represent the same thing. And if we get this one, we would say x is being squared, y is being squared, they're being subtracted. When squares are subtracted, that's a hyperbola. And if it's x first, then that means it's a horizontal hyperbola. If it was y squared first, that would be a vertical hyperbola. I put the one on the right just to note that we need to be a little bit careful with these because this isn't the format that exactly we would want. Because yeah, x is squared, y is squared. In this case, they're neither being added nor subtracted because they're on opposite sides of the equation. But if we put them into the same sides of the equation, now we would get x squared minus 2y squared, and we'd be able to make that same determination. So those are the basic rules. Again, it has to do with what's being squared or not squared, what's being either added or subtracted, and sometimes whether the coefficients are the same or not. But those are the rules that tell you which of the 4 conic sections an equation would represent.